had any questions, so I was kind of sad. People voted for me to play Diablo 2, so I did. But that game came out before, I'm guessing, all of you were born, so whatever. All right, what was I saying? We were on loops. Okay. Let me go back to what I was saying. What was I just ranting about? I lost my train. Oh, algorithms. Everything we've written so far, every piece of code we've written so far, whether it's in the lab, something you did on your own, something we did in lecture, something for the assignment, everything we've done so far is an algorithm. But we're about to learn very, very shortly our first real general purpose algorithm. That's, again, not to say that everything we haven't done so far isn't a real algorithm. Of course it is. Of course it is. But I think a lot of people would agree that what we're about to hit, linear search, is our first real algorithm that we could really make an argument of, now that's computer science. But I'll make sure it's obvious when we get there. All right, loops. If else is great for checking if something is true. Sorry, that's actually not correct. If else is great to give a condition to our program to do something if something is true, some condition is true. Otherwise, something else, right? If else checks one thing. And so it would be like, if you have a one-time check, if is great for it, right? But sometimes we want our code to do something over and over and over and over and over and over again for some number of times, or until some condition is met or something. So it's kind of like an if, but it's not like, oh, if this condition is true, run this chunk of code once and carry on. It's if this condition is true, keep running this code. And this is called a loop. Now, before I talk about loops, I just want to make sure I emphasize something that we've seen multiple times in the course already. But consider the following code. Take a second and look at this code. A equals 5, print A, B equals 6, great, right? There's nothing wrong with this code. There's no tricks here. Just what's the value of A at each print? That shouldn't be statement, really it should say function, but it's still correct. In other words, A is printed out 4 times. What values are printed out? On line 2, okay, everybody, I need y'all paying attention. Line 2, what will be printed out? 5. Line 5, what does the code say? Line 5, what gets printed out?
5.
Good. Why not 6? Well, because B is 6. A is still 5. A equals A plus B. Line 8.
11.
Whoa. All right. Yes. What will be printed out? 11. Why? Well, because A is 5, B is 6. You add those together, that's 11. You put it back into A, print out A, 11. Okay? And then line 12. Finally, on line 12, what is printed out on line 12?
4.
Why? Well, because A is now 3. A is 3 plus 1, that's 4. We stuff it back in A, print out A. Great. This code works just fine. We're reusing the variable A a bunch of times. That's the point of this, is there's nothing wrong with reusing that variable A and obliterating whatever value was in there and replacing with something else. That's normal. That's A-okay to do. We could write the same thing, basically the same functionality using different variables along the way, but here I just reused variables because why not? The point being emphasized is there's nothing stopping us from using variables. Now, we talked about this already, a very common pattern, A equals A plus 1. We learned a shorthand for that. A plus equals 1 is a way to say A equals A plus 1. It does the same thing. It's just a shorthand, and this is like syntax sugar, that thing I was talking about where, programmers have some nice syntax for some maybe common or important things they like to do. So the easy one is incrementing by 1 plus equals 1. If I wanted to have the same thing as a equals a plus 7, I would say a plus equals 7. Great. In other programming languages, plus equals typically works, but there's another shorthand for adding 1, but it only works with 1. Does anyone know what that is? No? I was just curious if anyone knew. In other programming languages, now this won't work in Python, but in some languages, plus equals is great. You say a plus equals 7, it means, a equals a plus 7. But it's very common to just always want to increment by 1. So they even have like a shorthand for that. So instead of writing a plus equals 1, what they would write is a plus plus. 2 pluses means increment. But that doesn't work in Python, but plus plus is just a way to increment something by 1. Has anyone who's ever used another programming language ever used that before? Raise your hand if you've used another programming language ever. Really high, I want to see. Keep your hand up if it was either C, C++, Java, yeah, those three. Did you ever do a loop in those languages? Then you've seen the plus plus. You probably wrote for int I equals 0, semicolon, I is less than some value, semicolon, I plus plus. Sometimes you see plus plus I. Same thing. You can put your hand up. Everyone else's hand went down. I figured, you can do it too. So plus plus is common, except a lot of times maybe you've used it in the loops and never really thought about it. But anyways, let's continue. Okay. Activity. Why not? Let's do an activity. No, we already did this the other day. We'll skip it. A is 5. What would A be after typing A plus equals 2? 7. Then, assuming A is 7, what would it be if I typed A times equals 2? 14. Why? Well, because it's the 7 times 2 and put it back in A. Great. It's just a shorthand. Okay, loops. There are a couple of types of loops. The two most common are going to be your while loops and your for loops. And for loops actually have two different kinds in a lot of languages, and there's something called like a do-while loop that I don't believe exists in Python. Maybe it does, but it's not a very popular or common type of loop. But we're going to start with a while loop. I think while loops are fairly intuitive. A while loop allows you to do while some condition is true, do the chunk of code in the loop. So it's just like an if. If some condition is true, do the chunk of code in the if block. But a while is while some condition is true, keep running the chunk of code in the while block. So, I want to write print hello world 5 times. Just as a simple little example. I want to do print hello world 5 times. If I want to do this without a loop, I would need to go, okay, I'm going to be lazy and just do hello. If I wanted to do it 5 times, 1, 2, 3, 4, 5. I hit run, and we see hello, 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 hello. Great. Right? Nothing special here. The trouble is, this wasn't too bad, right? I just copy pasted. But what if I wanted to do it 100 times? All right, well, 5, 6, 7, 8, 9, 10. And I guess I can do copy because we got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Great. I hit run, it prints out a hello 100 times. Great. Kind of annoying though. What's going on here? So here I've changed it back to 10. It's kind of annoying to do it like this, copy pasting. It also doesn't really scale very well, right? Someone comes along and says, no, do it 1,000 times. All right. So you have to go back and copy, paste, do it a bunch of times. Like it doesn't scale really well. Someone comes along and said, now do it 1,000,000 times. That's annoying. It's really error prone. Whenever you have like copy pasting the same code over and over again, just like with functions, remember how I was saying with functions, if you keep copying and pasting the same chunks of code, and maybe you need to go make a fix to those same chunks of code that exists 5 times in your program, and you make the one change, maybe in that chunk of code, you're always multiplying something by 2. But after a lot of deliberation, a lot of thought, and whatnot, you and your team of engineers decide you don't want to do multiply by 2, you want to do multiply by 3. So you go back and want to change that multiply by 2, and all the places that chunk of code that was copy pasted 5 times was done, but you forgot one, you did it to 4 places, you missed one, suddenly that chunk of code is going to be wrong, it's going to be a nightmare to debug. That's why you use a function. You can call the function 5 times, but if you need to change the code in the function, you just change it in one place, right? Same idea here. It's the copy and pasting. If I make a mistake on one of the lines, it's going to be a nightmare. So it's susceptible to bugs. And a lot of times, like I say, here, print out 5 times, print out 10 times. But you remember on Caddis, who here was working on one of the Caddis problems it's possible that you came across one that said, the first line of input is going to be how many cases you need to solve. So if it's 4, then the subsequent 4 lines of input will be the different cases you need to solve. Anyone here see that on Caddis yet? A couple people. If you got pretty far ahead, you would have come across that one. So what it's saying is, you need to read the input X number of times. But you don't know how many pieces of input you need to read until Caddis tells you. So Caddis might say, I'm going to give you 7 pieces of input. So you need to read input 7 times. Caddis might say, I'm going to give you 4 pieces of input. So you need to read input 4 times. If I'm hard coding the number of times I'm doing input to 10, what happens when Caddis comes along and says, read input 17 times? You're out of luck. So it doesn't, this copying and pasting strategy doesn't allow for us to have a variable number of times we want something to happen, which is another big limitation. Yeah, for example, what if I want to print n times where n is some parameter of the function? So here is an example of a loop, a while loop, a very simple while loop. Raise your hand if you've never seen a while loop before in your life. Okay, despite this, let's see if we can figure this out based on what the code says. Because remember, there's one trick. What does the code say? Make no assumptions, never generalize multiple lines of code at a time. What happens? Counter equals 0. What value does counter have? 0. Well, counter is less than 10. Well, what is counter? 0. Is 0 less than 10? No one said yes. Well done. So while that's true, print out counter. So what do I see printed out? 0. Then I say counter plus equals 1. So on line 4, after line 4 finishes, what value does counter have? 1. So we go back up to the start of the loop. Counter is 1. Is 1 less than 10? True. So we print out 1. Now counter is 2. Is 2 less than 10? 3, 4, 5, 6, 7, 8, 9. Is 9 less than 10? True. So because 9 is less than 10, I print out counter. Counter's 9. I add 1 to counter. Counter becomes what? 10. So now I ask, is 10 less than 10? False. False. Loop stops. As soon as the condition is false, it stops. So, when I run this, think to yourself in your head. You don't have to say anything. In your head, what's going on here? When I hit run, what do you expect to see? Did that match your expectations? True, yes. Thumbs up, nod. Awesome. Starts at 0, 1, 2, 3, 4. But notice it doesn't go up to 10. I say less than 10. If I really wanted it to go up to 10, I could do like less than 11. Right? Now it'll go up to 10, or I could do less than or equal to 10. And then it'll go up to 10. But here's something I want you to take note of. How many times did that loop run? Don't shout out the answer if you know it already. If you don't know, count. Tell me, how many times did that loop run? I'll give you 4 seconds to count. Okay, everyone shout out the answer. How many times did the loop run? 10. And you're thinking, yeah, but it didn't run that 10th time. You're right, but it ran on the 0th time. So it ran 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. Because we count that 0. The 0th time through that loop it ran. Remember, computer scientists like start counting at 0. So 0, we count. Cool, right? So what's neat here is if I wanted it to go to 100, I don't need to copy and paste anything. I just go, all right, 100, great. Let's go to that number. What, I don't even know what number that is. 1, 2, 3, 1, 2, a million. So it's going to count to a million. Interesting note, you'll see it's still going. Interesting note, the computer can count to a million like that. What the computer has a hard time doing, what the computer is really slow at, is output. The print is the bottleneck here. Let me give you an example of what I mean. You can clearly see this is still running. It's at 76,000, 78, 80,000. It's going to go to a million, so it's going to take a while, right? We're not even a 10th of the way done. So I'm going to stop it. I'm going to try to stop it. Come on. Oh, I got to hit that button. All right, so it stopped it. So instead, what I'm going to do is I'm not going to do print in the loop. Because when print's in the loop, and the loop needs to run a million times, how many times will print get called? 1 million. Instead, I'm not going to put it in the loop. I'm going to let the loop run, and then do a final print counter. So I'm only doing a print once. So I'm going to let it count to a million, then print. Let's see how quickly it runs. Like that, right? The prints are really slow, just FYI. Let's see how big we can make it. So 1 million, 10 million, 100 million, 1 billion. Oh, this one's taking a while to get to 1 billion. It's taking longer than I thought. All right, I give up. I wonder what it got to. Does it say? If I hover. Ooh, it does. What is that? 1, 2, 3. 1, 2, 3. It got to 109 million. Not too bad. Yes.
When you print it outside, why is it only output the last number?
Why it only prints out the last number? Because I only, the loop runs. Counter keeps getting incremented every time. The loop finishes, but counter is left with a value, and then I just say, okay, print it out. So it's only told to print after doing all the counting. Now, let me go back to the 10. So here it just counted to 10. But the loop, we saw the loop only went to 9, right? When I had the print inside the loop, it only went to 9. Let me go back and show you that I'm not crazy. Right? 0, 1, 5, 7, 9. So this time it prints out every time because the print's in the loop. Print, 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 right? But we'll see, what's the last thing printed out? 9. But remember, let's see what happens when, okay, counter's 9. Is 9 less than 10? True. Print out counter, so you print out 9. Counter, add 1, counter becomes 10. So counter did become 10. It's just that when we went back up to check the condition in the while, is 10 less than 10? No. Okay, we stopped. But counter still has that value 10. That's why, if I go here now, after loop 10. So we see all the prints in the loop, and then I have the print at the end to say, all right, after the loop is finished, it has the value 10. For those of you wondering, this is called an F string. It's just a fancy way to format, to type your syntax sugar. for your print statements. Yes?
What do the things around counter mean?
Oh, the squiggly brackets? This is just the syntax for doing it with an F string. So you'll notice I put the letter F before the quotes. If that's not there, this won't work. Well, it will work. It'll just assume that I say literally print that out. This F string is just a fancy way to give you syntax to say, okay, within the squigglies, I'm going to give you the value I actually really want you to print out. So that's why when I hit run, we don't see the squigglies, we don't see counter, we see the results of the variable counter there. This is just an F string. I could do this another way of just doing like after loop. I can do it with concatenating strings. It would work just the same. Cool. Good question. I talk about F strings in a couple of topics. I just thought I'd show off a little bit right now. Okay, so the above example will print out the numbers 0 through 9. I just explained. Okay, great. What would happen? Okay, yeah. Here's a thought experiment for you. What would happen if I didn't write counter plus equals 1 within the loop? Let's just, I'm going to comment this out as if it's not even there. I'm not going to hit run yet. Take a moment and think about what's going to happen. And if you don't know immediately, you're normal. But remember, the one trick is, what does the code say? Start writing the code for a couple of iterations and see what happens. See if you can find out what the problem is here, or if there is a problem. Take a second. I'll give you a second. Think about it. And when you think you have an answer in your head, just raise your hand. I'm not going to quiz anybody. It's just when you think you have an answer, put your hand up, because I want to see how many people kind of think they've got something. I'll give you a second here. I think I see about half people. So what's happening? Counter equals 0. If you don't know, what's the trick? Read it. Counter equals 0. Is 0 less than 100?
True.
Print out counter. What's counter? 0. You print out 0. Great. Go back up to the top of the while loop. Is 0, what's counter? It's still 0. Counter was never changed. So is 0 less than 100? True. Print out counter. It's 0. Go back up. Is counter less than, I said 100 I think last time. I meant 10. Is counter less than 10? Yeah, it's 0. Print out 0. Go back up. Is counter less than 10? Yeah, it's 0. Print out 0. And so on and so on and so on. So what would happen? Someone yell it. Infinite loop. It loops forever. It keeps going. Let's see what happens. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. This loop will never stop. It will run forever until the power goes out. It'll run forever because the statement within that while condition, based on the code there, will always be true. Because 0, counter is 0. Counter never changed. Is 0 less than 10? 0 is always less than 10. So it's true. It is akin to writing literally this. While true, do that. If you do while true, that loop will run forever, because true is always true. What would happen if I wrote while false? It's not a trick question. Would this loop ever run? False. You're right, it would never run. We're only seeing the last print here. Because while false, well, it's false, so I don't execute what's in there. This would be a rather silly thing to write. Great. Now we're back. Oh, still the infinite loop because I forgot to add the increment back. So that increment is super important for it to work. Because otherwise, that condition, the values being compared would never change. So it wouldn't work. Okay. Tracing through a function by hand. This is just what I was talking about. What does the code say? So, trace through the code below by hand for few values of n. N is just some parameter here. can you figure out what this function is doing? We're at the stage, notice how we're what, like a month into the semester, and we are now at the stage where we're looking at code that's complex enough that you have no business, I don't care how experienced you are, you have no business looking at code going, I know what that does. You don't, no, you don't. The only way you're going to find out what the code does is by looking at it and reading it and thinking about what it does. You are not expected. It would be ridiculous to expect anybody to be able to just look at code and know immediately. So this is code that's gotten too complex that there's no way you could be able to look at this and know immediately. So you need to take the time to look at it. What does it say? So I'll give you a couple moments here. If you've got pencil, paper, great. If you've got something in front of you to type with, keep track of some values as you go. Try running this where, you pass value 2, 4, 5, whatever. What does this function do? Obviously, this function has a very poor name in describing what it does. It's just called trace through by hand. Trace through me by hand. But it has some functionality. So take a couple minutes, see if you can find out what it does. Raise your hand when you think you have an answer in your head. I'll give you a couple more minutes. It's a tough one. It also doesn't help that this function is deliberately written in a way to be confusing. But that doesn't stop you from being able to follow what the code says. Raise your hand if you think you know now. Okay, a couple more people. So let's do an example. Let's say I go with the value 4. There's an example down here with the table, but we're going to work through it. So, n is 4. I'm not going to be able to keep track of these values in my head, so I make a table to do it. And I'm not being silly and overemphasizing the table, like I would need to do it this way. I just can't keep track of these two values in my head. So n is 4. Result is 1. Okay. Why? Well, I start running the code. Result equals 1. Then I say when n is greater than 1, well, 4 is greater than 1. Result equals result times n. Okay. So result is getting changed to what it was when it was 1 times n, which is 4, so result is 4. Okay. And then n minus equals 1. What does n become? 3. Great. Okay. So this next time through the loop, result starts as 4. By the way, the way I'm writing this out and how I'm crossing it out and updating it, this is just the way I like to do my tables. Keep track of this data however you want. This isn't like a formal correct way to do it. So n is 3, 3 is greater than 1, so that means result, which is 4, times n, which is 3, so 4 times 3 is 12, right? Did someone say true? Nice. And then n minus 1, so okay, so it becomes 2. And then for the time, n is 2. 2 is, of course, greater than 1. So I take 12 times n, which is 2. Oh, sorry, it starts as 12. But then I multiply it by 2 because its result, which is 12, times n, which is 2. I get 24. Great. N becomes 1. I go back up. Is 1 less than 1? No. So we're done. We return result 24. So I got the value 24. Great. Did anyone trace it through like this and get 24? Did anyone just go like, well, it says 24 right there, so whatever. Did anyone trace it through and get it with any other values of n? What'd you get? What values of n did you use?
I used 5 and then I got 120.
You used 5 and got 120. Okay, so apparently 5 will get you 120. Any other values of n anyone use? No? Who here knows what that function's doing? Raise your hand really high if you think you know what it's doing. Okay, a couple people. Okay, keep your hand up if you want to take a stab.
Is it a factorial?
It's factorial. Raise your hand if you know what the hell the word factorial means. About half of you. Factorial is a fancy way of saying, in fact, I think, one second. Oh no, did I get rid of the little, oh no. I think last year, must have been years before, I must have got rid of it. I used to have like a little, tell me what it's doing with an exclamation point, because it's funny. So what factorial is, there's a special symbol in math for factorial. If I write 4 factorial, exclamation point, what that means is 4 times 3 times 2 and times 1 because why not? So it means take that number and multiply it by every preceding number. 5 factorial would be 5 times 4 times 3 times 2 times 1. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. It's factorial. What's kind of neat about 5 factorial, or factorial in general, what's really cool about it is notice that 5 factorial, which is 5 times 4 times 3 times 2 times 1. I realize it's getting small for those of you at the back. But notice that 5 factorial is actually equal to, 5 factorial is also equal to 5 times 4 factorial. That's 4 factorial. So to get 5 factorial, it's actually just 4 factorial times 5. 10 factorial would be 9 factorial times 10. But of course, 9 factorial is actually just 8 factorial times 9. And so on and so on and so on. So factorial is kind of fun. If, we're not going to do this activity for the sake of time, but if I were to say write a function int sum that takes a single integer n as a parameter and returns the sum of all numbers between 0 and n inclusively, so include n. So if I said 5, I'd want 0 plus 1 plus 2 plus 3 plus 4 plus 5. How would you do that? Well, There's an example right there. The thumbnail's giving it away. By the way, has anyone watched any of these like videos that I made a couple years ago to help? For those of you that have, it is noted, but they are written in Python 2. So you will see this print here, for example, doesn't have parentheses. If you did this in Python 3, it wouldn't work. You need the parentheses, so just FYI. Anyways, this right here, int sum, although we're not doing it right now, this would be an activity I would, you know what are we doing here? We've got 5 minutes. Do this activity. Try not to look at the answer in the thumbnail. Take your time with it. You're gonna need a while loop. You're gonna need variables. You're gonna need to check a condition. See if you can do this int sum. But remember, I want it to be inclusive. So if you put 5, make sure 5 is part of it. And if you're really stuck, maybe use this as a starting point. I'll give you like 3 minutes to do it, maybe 4 minutes, and then I'll work through a solution. Is it a little easier? Let me be very clear, this is a non-trivial function to write. Especially when it's the first time you're writing a loop. Non-trivial. Raise your hand if you have a solution. Raise your hand if you totally would have a solution if you had like one more minute. Okay, because of time, I won't give you that minute, but let's work through it. Here's what I've started. We can't overthink this. That's the first thing you gotta be aware of. Do not overthink it. If I want to sum all the numbers between 0 and n, and the n is something I'm passing to, well, I'm going to want a loop that starts with 0, goes to 1, 2, 3, all the way to n. But we want to include n. So all I've done is I said, okay, counter equals 0, starting at 0. Well, counter is less than or equal to n, because I want to include n. I've just set up my loop. Then I'm going to want to do something inside that loop. I don't know. But of course, I do know every time after that loop's kind of like run, I want to increment counter, right? So the first time it's 0, it does its thing, and then it becomes 1. And then it does its thing, and then it becomes 2. And then it does its thing, and then it becomes n. It does its thing, and then it'll stop. So the key here is, what on earth do I need to do in the middle? The trick to solving this one is knowing, or the trick to solving this is using a second variable. We'll start running sum equals 0. So, running sum equals running sum plus, well, the first time through the loop I wanted to add 0, which again is kind of silly, but we'll do it anyways. But counter has the value 0. Increment counter, counter is now 1. Then I want to take running sum, add 1 to it. The value of counter. That becomes 2. Add 2 to it, 3 to it, 4, 5, and so on. Then finally, the final result will be running sum. So now I need to actually int sum. There we go. 15. And if you don't know why it's 15, trace through the code. Who here wrote it basically exactly like this? Who here wrote it by taking the one we just did with the multiplication, but changing it to addition instead? Well, good thinking. I personally find this a little bit more intuitive, but okay. We could, of course, do it like this. No, not like that. Oh no. Well, I guess the goodest place to end is to stop because I broke it.